Okay, now we have done building our basic gates on breadboard. Now I'll show you how to make gates out of these three gates. These three gates, and we will use some combination of these three to make some other gates. So we have next one we have is NOR gate, which and its a symbol looks something like this. A and B and Y, which outputs. Okay, let me make a truth table for this. So here is the truth table for NOR gate. So is the Y, which is A equals B to the power. So yes, if you guessed it, you're right. So it basically what it does is it inverts the OR of A plus B. So it is exactly like this. We can build a NOR gate with a combination of OR gate in series with a NOT gate. So that's become a NOR gate. So it will give us the, okay, let me add the OR gate too, and we'll try to build it, which is, this is the OR gate. We have four possibilities at the input. Again, let me write it. Now we can have, now I'll copy the OR gate to table here. So this is the OR gate. Now we will just invert these values and write it here. So for 0 we'll get 1, for 1 we get 0, for 1 we get 0, and again this is 0. So that's how the NOR gate behaves. It will give you one only when you put off both the inputs, otherwise it will give you 0 zeros at the output. So that's how you build a NOR gate with the combination of NOR gate and NOT gate. Another one is the NAND gate, which is again the inverse of AND gate, and which has a symbol something like this. Differentiate with the symbol of OR AND gate by just this dot. You can build it AND gate and NOT gate in series at the output of AND gate. Now let me build you the truth table. For the NAND gate, this is our input A, this is our input B. Here I'll show you the output of the AND gate, which is A multiplied B. The output of NAND gate here, which will be A multiplied by B inverse. So I'll copy the NAND gate truth table here, and we'll see how it works. These are the possible inputs for two inputs, for which we'll get this. Now we will just simply invert this. Okay, that's how the NAND gate behaves. So it will give you 1 at the output for all the combination, if you have a single input as if you have at least a single input as 0, you will get the 1 at the output. If you have both the input as 1, you will get 0 at the output. Yeah. Okay, that's how the NAND gate behave. Now let us move on the another gate